Hello friends, good morning to all of you. In today's lecture, we are going to study projectile motion part 1. Okay, this is part of the chapter motion in a plane, that is chapter number 4 of physics NCERT for class 11th. Before I start, I would like to request one and all to subscribe to our YouTube channel and click on the bell icon to receive the future notifications. So we will start with definition of projectile motion. So what is a projectile motion? Okay, so projectile motion is a type of motion in which object is in flight after being thrown or projected. I am repeating, projectile motion is a motion in which object is in flight after being thrown or projected. Okay, so Galileo was the scientist who discussed projectile motion in his book Dialogue on Great World System, written in 1632. So in this part of his work, he talked about the projectile motion. He told projectile motion contains two types of motion. One is horizontal motion and another one is vertical motion. Both the motions are independent of each other and both the motions are simultaneously acting. Means independent and simultaneously acting vertical motion and horizontal motion, that is projectile motion. So we will talk about examples of the projectile motions. Suppose you are firing a bullet from a gun. After the release of the bullet from the gun, the path followed by the gun bullet will be projectile in nature. Okay, so in fact the path of the projectile is called as trajectory. Okay, the path of the projectile is called as its trajectory. Okay, and suppose you are kicking a football. Okay, so that is an example of projectile motion. The path followed by ballistic missile. Whenever you are firing a ballistic missile, its path will be parabolic and trajectory will be parabolic, and it is an example of projectile motion. Okay, whenever you are throwing a cricket ball, that is also an example of projectile motion. Suppose somebody is jumping from a cliff, that is also an example of projectile motion. Okay, so we will talk about terminologies associated with projectile motion. As we have already told that trajectory is the path followed by the projectile. Okay, so there will be two simultaneously acting motions. One is horizontal, another one is vertical. Suppose a projectile is fired making an angle theta with the horizontal, So at any instant, the instantaneous velocity will be given by tangent to the curve, and its instantaneous velocity can be resolved into two components. One is the horizontal component, another is the vertical component. This horizontal component and the vertical components are the simultaneously acting together and they are independent of each other. Okay, so projectile motion happens whenever object is moving under the influence of gravity alone. Means there is only one force acting on the body, that is gravitational force. Okay, somebody may ask the question, suppose a body is thrown, so there is ought to be a force known as air resistance, but we are considering that the effect of the air resistance is negligible in comparison to the gravity. So projectile motion is a motion in which the force of gravity is only present, there is no other force present. Okay, so we are taking velocity u, and velocity u is resolved into two components, horizontal component and vertical component. Horizontal component will be given by u cos theta and vertical component will be given by u sin theta. U cos theta is the horizontal component of the velocity and u sin theta is the vertical component of the velocity. Okay, so these are two component. Okay, so now at the highest point, the object will cease to move upward. So at the highest point, the vertical component of the velocity will become equal to 0. There will be no vertical component and there will be only horizontal component. Okay, so and after reaching the highest point, the vertical component will start applying downwards. Okay, there will be uy is equal to minus u sin theta after reaching the highest point, and horizontal component will remain same. In fact, when we consider there is no air resistance acting on the projectile, the horizontal component of the velocity will remain same throughout the trajectory of the projectile, and vertical component of the velocity will keep on changing. So ux is called as the horizontal component of the velocity and uy is called as the vertical component of the velocity. Okay, so horizontal component of the velocity, okay, will be along the x-axis and vertical component of the velocity will be along the y-axis. Now we will talk about acceleration. How will acceleration act? Okay, so now we know that acceleration due to gravity is the only acceleration that will act on the projectile. There will be no other acceleration except acceleration due to gravity, and acceleration does not occur sideways, it always occur downwards. Acceleration due to gravity always occur downwards, it does not occur sideways. So acceleration along the x-axis will be equal to 0 and acceleration along the y-axis will be equal to minus g. Why minus sign? It is acting downward. Okay, and there will be no component of the acceleration acting along the x-axis. Okay, so ax will be equal to 0 and ay will be equal to minus g. Now we will talk about range and maximum height. Range is the total distance traveled between the point of projection and at the lowest point in the trajectile where the projectile completes its journey, and maximum height is the maximum distance traveled along the y-axis. Maximum distance, highest point in y-axis, the highest vertical component, vertical point on the trajectory of the projectile is called maximum height. We will move to next slide now. We will talk about components of velocity at time t. We know that there is velocity v0, that this is instantaneous velocity. It is resolved into two components, vx0 and v0y, v0x and v0y. So one is horizontal component along x-axis, another is vertical component along y-axis. Okay, so now horizontal component will remain same throughout the trajectory of the projectile. Trajectory means path of the projectile. Horizontal component will remain v0 cos theta, theta or theta 0. Horizontal component will remain same. Why horizontal component remains same? Gravity does not occur sideways. So gravity does not occur sideways, so there will be no acceleration due to gravity sideways. It will be only downward. Okay, and apart from that, we are ignoring air resistance. If we will consider air resistance, then horizontal component of the velocity will not remain constant, but for all the practical purposes we are assuming air resistance is negligible in comparison to acceleration due to gravity. So whenever we are talking about component of the velocity at time t along x-axis, we are considering it constant, that is Vx is equal to V0 cos theta 0. That means horizontal component of the velocity always remains constant throughout the trajectory of the projectile. Now we will talk about vertical component of the velocity, Vy. So we know that the acceleration due to gravity is occurring downwards. We know that v is equal to u plus at. So u is nothing, v0 sine theta 0, and a is equal to minus g. So we will get vertical component of velocity vy is equal to v0 sine theta 0 minus gt. And how will you calculate? Velocity v is equal to vx square plus vy square. That's how you can calculate velocity at any point of time by applying the vector law of addition that has already been covered in the previous videos. Okay, so vx is equal to v cos theta 0 and vy is equal to v0 sin theta 0 minus gt. These are two components of velocity. Both are independent of each other and both are simultaneously acting at the highest point of the trajectory of the projectile. The vertical component of the velocity will become 0. Why vertical component of the velocity will become 0? At the highest point, what will happen? Object will cease to move upwards. Object will cease to move upwards. So object will not move upwards. So what will happen? The vertical component of velocity will become equal to 0 at the highest point. But the horizontal component of the velocity will remain same. And after reaching the highest point, during the descent of the projectile, the horizontal component will remain same in the same direction, but vertical component will apply downwards. And during the ascent of the projectile, vertical component of the velocity will occur upwards. Okay, so these things you need to consider. Okay, so now we will move to next slide. So we will talk about position at time t. Position at time t. We know that s is equal to ut plus half at square. S is equal to ut plus half at square. When we will talk about the horizontal position, we will talk about horizontal position. So x will be given by horizontal component of velocity into time taken. We are taking position at time t. Horizontal component of the velocity will be equal to v0 cos theta 0 into t. So x is equal to v0 cos theta 0 into t. This is the position, horizontal position at time t. Okay, and there will be no sideways acceleration and air resistance is not considered. So we will not consider any acceleration. So x will be given by v0 cos theta 0 into t. So now the vertical position will be given by v0 sin theta 0 t minus ka half gt square. So v0 sin theta 0 is nothing but the vertical component of the velocity, and a will be equal to minus g. A will be equal to minus g. So putting in the formula s is equal to ut plus half gt square, we will get y is equal to v0 sin theta 0 t minus half gt square. These two equations we are getting. X is equal to v0 cos theta 0 t and y is equal to v0 sin theta 0 t minus half gt square. So what we will do? We will put the value of t from the equation 1 in equation 2. We will put the value of t. T will be equal to x by v0 cos theta 0, and we will put in equation 2 in place of t. And then when we will substitute value of t from equation 1 to equation 2, we will get y is equal to x tan theta 0 minus ka g x square y2 in bracket v0 cos theta 0 whole square. Okay, so we know that y is equal to ax plus bx square. Ax plus bx square. Y is equal to ax plus bx square. So what is this? This is the equation of parabola. Y is equal to ax plus vx square. Y is equal to ax plus vx square. It is of the form y is equal to ax plus bx square, where a is tan theta 0 and b is what? Minus ka gy2 within bracket v0 cos theta 0 whole square. So we know that we are getting an equation of parabola. So that's how we can prove that path of a projectile is parabolic in nature. So path of the projectile also known as trajectory. In other words, we can tell that trajectory of a projectile is parabolic in nature. Okay, so we have proved it. Okay, so this is for a projectile fired at an angle theta 0 with horizontal. Okay, and we are observing it in our day-to-day life. Whenever we are throwing a cricket ball in air or to another person, we are observing that trajectory of the cricket ball is parabolic in nature. Same is the case for football. You are kicking a football, the trajectory is parabolic in nature. So path of the projectile is parabolic in nature. We have proved it. Okay, that's all for today. In our next video, we will discuss further topics of projectile motion. Thank you. Thanks for listening. Thank you.